if you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater, but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I am Guna Mathivanan from Offices IAS Academy. In today's video, we are going to discuss about life in ocean, Twilight Zone. So, if you look at the oceans, based on the depth, we are dividing that into epipelagic zone, mesopelagic zone, bathypelagic zone. So basically, the first 200 meters will be called as epipelagic. From 200 to 1000 meters will be called as mesopelagic, which is called as the twilight zone. So this region, the sunlight will be dim. In the twilight zone, the sunlight will be dim. It will be colder. Okay, so the commercial fishes, those fishes we commercialize, that you will find it in the first 200 meters. So fishermen will be hunting all those fishes from this first 200 meters. In the mesopelagic zone, what you will find? You will find microorganisms, zooplanktons. You will find some kind of fish, squid, crustaceans. Crustaceans means shelled species, right? Gelatinous animals, jellyfish. All these you can find in this mesopelagic zone. This zone is very important for various reasons. But before that, I said this zone is darker. Relatively, I mean, because sunlight will be reducing, so it will be dim, it will be cold. So the species in this region, to survive for light, they have some adaptation. So they will exhibit a property called as bioluminescence. Bioluminescence. So the species in that twilight zone, in that region, right, they will emit light. They will emit light for their survival. There are some predatory fishes. They will also emit light to catch the prey. So here I have given the image of angular fish. Angular fish. So this fish, if you see at the head, you will be having some bulb-like part. Okay, a bulb-like part. It is not a bulb, but a bulb-like projections you will see that will glow. That will glow during the night time. That will glow. So like this, it will glow. So what happens is fishes. So they, by looking at the light, they will come closer to this predatory fish. Now the predatory fish will go and catch all those prey. So this is an interesting factor. So bioluminescence is a property exhibited by those organisms living in this twilight zone. Okay, so this bulb facility, that is the bioluminescence organ, which is called as ESCA. It's called as ESCA. So many species have this feature. I have given the example of angular fish. Okay, I think in Finding Nemo movie also you will see this fish. Okay, so yes, this is some adaptation property. Now let's discuss about the significance, importance, why this zone is important. See, these bigger fishes are very important, which has commercial values. So our fishermen, we will go, will hunt these fishes, which has commercial value. And these fishes, for example, whales, sharks, these fishes, they will dive down, and they will eat the organisms in this twilight zone. So the organisms in the twilight zone is the food for the fish species which is found in the epipelagic zone, right? So what happens is, many a times the fishes from the top, they will dive down, they will come and they will have food from the twilight zone. So if you want to have healthier fishes, commercially available fishes at the top, then this twilight zone has to be more protected also. So put it simply, this twilight zone, the fishes, the organism species, the zooplanktons, the crustaceans, which is available in the twilight zone, those are acting as food for the bigger fishes in the top. The bigger fishes in the top, they will dive down, they will eat those items. And not just that, see, in the surface, So in the surface, what happens is, the surface you will have lot of phytoplanktons. The surface you will have lot of phytoplanktons. These phytoplanktons, okay, they are closer to the surface, so they will be receiving more sunlight. With the help of sunlight, they will perform photosynthesis. For photosynthesis, they need carbon dioxide. So these phytoplanktons in the surface, they will start absorbing carbon dioxide from the atmosphere. The phytoplanktons floating in the surface, they will absorb carbon dioxide from the atmosphere and they will start growing. They will convert the carbon dioxide into matter and energy. So that this ocean acts like a carbon sink. Right? These phytoplanktons, they will capture the carbon and they will store it with itself. Now what happens is these phytoplanktons will be finally consumed by zooplanktons, and you see a lot of zooplanktons in the mesopelagic zone, that is in the twilight zone. So these zooplanktons in the twilight zone, what they will do, they will go and depend on the phytoplanktons. So what phytoplanktons do? It is going to capture carbon dioxide. Now what zooplankton will do? Zooplankton will go and eat those phytoplanktons. So the carbon dioxide from the atmosphere, the CO2 from the atmosphere, now it will go to the first layer, later it will go to the second layer. This feature is called as biological pump. Oceans act like a biological pump. So what happens is, the carbon dioxide from the atmosphere, it reaches to the down layers, and majority of them which is captured, that will get synced in this twilight zone. So 90% of the carbon dioxide captured will sink in this twilight zone. So this twilight zone is very, very important because it stores a lot of carbon dioxide from the atmosphere. And not just that, these phytoplanktons in the top, once these phytoplanktons die, what happens is, it will start sinking downwards. Okay, so that is referred as marine snow. So these dead phytoplanktons, which has carbon dioxide in its body, once it is dead, it will start sinking down. So once it sinks down, then all the species in the mesopelagic zone, they will start consuming those phytoplanktons. Right? So in a way, carbon dioxide is captured by phytoplanktons, and those phytoplanktons is finally consumed by the species in the mesopelagic zone, that is twilight zone, and the carbon dioxide is stored inside the oceans. Right? So this region plays a crucial role. It helps, it acts like the carbon sink. It also provides food for the fishes at the top. It will dive down and it will consume food from the bottom. So marine snow, I explained, these dead phytoplanktons, they will be sinking down. So it will look like as if snow is flowing down inside the water. Right? So that acts like a food for the zooplanktons and other marine organisms in the twilight zone. So yes, why it was in news? So a global research was saying that this global warming can lead to end of 40% of species in this twilight zone. Because of global warming, 40% of species in the twilight zone can come to an end. That is the warning which was given by a global research study. That's why it was in news.